Hi guys, welcome to my video blog again. It's a quick response actually from one friend of mine who's got trouble with H-bridges. It's quite late. You can see at the clock, it's 8 o'clock. So yeah, so I'm gonna make this quick tutorial about H-bridges, how they work, and actually I'm gonna focus on the Mosfet type H-bridges, because this is the ones my friend got problems with. Now actually what H-bridge is, when you get motor, standard brush the motor, once we change polarity we change direction of spinning, so we need some sort of a switching. So H-bridge basically consists of 4 switches. Now this is the basic circuit of an H-bridge. The switches should be activated in pairs, like so, to drive it forward, or in pairs like so to drive it to actually brake the motor, because then this electromagnetic stuff from motor actually starts working as brake. So it's not a really strong brake, but at this modified servo motors it can be quite useful. But in none of the case we should toggle this one. It's no. Everything can just blow up, and that's bad. Now when we know what H-bridge actually is, let's design a Mosfet one. So first of all, let's put in a motor. And we're gonna use 2 types of Mosfets, P channel and N channel. Usually you can't use just one type of it, so you're pretty much forced to use both. So let me just draw this schematic. So this is pretty much the basic Mosfet H-bridge. This should actually work pretty fine. Also, there's not one thing you should note. In the Mosfets there are built-in surge diodes. So there is a small protection between this EMF protection, because motor is acting as a big inductor. Once you put the charge in, it's built up, and once you shut it down, it wants to flow, and it converts into high voltage, and this can damage your transistors. That's why we use these diodes to actually neutralize this charge safe way. So actually these diodes are already built in most Mosfet transistors. Those are actually Zener diodes, and their purpose actually is so the voltage between source and drain isn't too big, so it doesn't hurt the Mosfet. Now, how do Mosfets actually work? There are 2 types of Mosfet, as I said. An N channel I'm using at the bottom, and P channel used as the top. All the Mosfets have 3 pins called drain, gate, and source. And on schematics, drain is the one I'm going to draw this. The gate is this control one. You pretty much can't swap them. Then the source is at the side where there is additional line, or in other sometimes it's drawn like the gate is at the side of the source. This is the standard symbol for all the field effect transistors, but this is especially for Mosfet. So line indicates source, and the third one is drain. So as you might note, the polarization between drain and source, in this case between P and N channel, are swapped. So source always goes to some supply pin in this case. Now, when MOSFETs actually act like some sort of a switch, when they're activated, the current, their resistance is low, and when they are not activated, the resistance is high. And now, what's this difference between P and N channel? Actually, the MOSFET is activated when the gate voltage, or actually voltage, it's actually a voltage between gate and source. You should know that this is a common mistake, and I'm gonna tell you what's actually so bugging about this one. It's actually this guy's voltage depend if it's on or off. So if we're using a N channel MOSFET, the voltage on between gate and source should be higher than threshold voltage. So it's pretty logical. And in P channel, voltage gate to source should be smaller than threshold, but in P channel MOSFET, threshold voltage is negative. So there is this voltage, actually there is in N channel it's positive, and in P channels it's, of course, as I said, negative. So this should be, let's say, imagine with some numbers. Source there, in our case, is 0 volts or ground. So once the I'm using ERF 530 and 9530 for example. Let's say that gate voltage threshold is 3 volts. So once the voltage is between these two is higher than 3 volts, this MOSFET is activated. But what happens at the P channel? These are commonly actually misunderstood. You should know that source here is at the voltage level of these, and sometimes people put these guys like on 12 volts, and they want to drive this pin directly with 5 volts logic. And what's the problem? Voltage threshold here says minus 3 volts. So even to this voltage is positive or 5 volts, 5 on TTL level, it's not on the level of this current MOSFET. So what you should do, actually, if you want to deactivate, you should actually drive gate at the voltage of 12 volts. Pretty logical. So if you want to drive these guys, the best idea is to put a resistor between gate and source, and then pull it low with another N channel, or just a bipolar NPN transistor pulled to ground. And also, what this does, this acts like a NOT gate. So it's NOT gate actually, and this actually solves many problems with these guys. So you don't have to change stuff in software about the high and low levels. So you do the same, of course, on the other side. So this is one thing people many times do wrong about these MOSFETs. If you drive this directly on 5 volts level, and let's say you got 12 amps, it's actually 12 volts, sorry, talking crazy, it's late as I said, then this MOSFET is going to be activated the whole time. And once you activate this bottom MOSFET in combination with this already activated MOSFET, and you actually want to just this one to be activated, they're both activated, And what happens is that there comes short, everything starts to heating up, and you can potentially burn your circuit. So that's bad. Now when we went through the theory, let's actually make a full Mosfet H-Bridge schematic. So we've made through the tutorial, the main part of the tutorial. So about this resistor wise, I added another pull down resistor here because these guys are static sensitive, and when you turn the device off, it's quite bad to have all this stuff floating around. So these are pull down resistors. Probably there's not actually a real matter what wire there are. Probably a 10k ohm resistor will do just fine. So that's one thing. And I'd also like to know just one thing. If you're working with voltages higher than max gate voltages, is then at the P channel you should add another resistor between this resistor pulling things down and driving gate in the ratio calculated as voltage divider that won't actually hurt the transistor's gate. But since most of the voltage maximum voltage on gate is about 20 volts at most MOSFETs, this is not really a matter of problem. Actually, that's also why you use these pull down resistors, so static charge doesn't build up too much voltage at too much current to hurt these MOSFETs. Actually, these are very static sensitive. It's quite funny because they hold up 10 amps of current, but they can't hold us few milliamps of static. So yeah, that's why you should work with them with static free environment, and of course protect them with pull downs. Now, because this transistor acts as a NOT gate, all the activation is at same polarity, so this is pretty much what you want. It's simple circuit, it works perfectly. It's recommended to add some more of these surge diodes because these parasitic diodes in MOSFETs are there's small tiny current ones, and it's recommended to add some Schottky diodes. They're the best for this this appliance, because they're sometimes also referred as the perfect diode, so name talks for themselves. And that's pretty much it. Also, because of the EMF, it's recommended to add some capacitor there, so once the opposite charge happens, this capacitor acts as resistor discharge, neutralizing this charge too, because it actually reacts as the AC current, and capacitors that AC current actually some sort of conduct and stuff. It's actually quite about this EMF. There is a lot of talk and a lot of dust about this. So basically the most reliable methods are some Schottky diodes and of course capacitance, but you should also know that this capacitor is gonna make the response a bit smaller if it's too big, so yeah. And also it will discharge slowly if it's too big and cause the motor to stop slower than normally. But if you apply brake at this point, it will start stop much faster, since it will just actively short everything. So thanks for watching, hope you liked the video and hope you learned something new. See you next time.